By the way, there's something annoying about this software, and it's that you can't make a cross of wire. Like, say I want to connect this wire here. It will give me an error later on. So I just take it and connect it here.
Single connection?
Hmm?
You mean single connection for 2 wires?
Yeah, you can't make more than 3 wires from a dot. It has to be only 3. Okay. Okay. Now I need to... Oh, sorry. I need to size my transistors, right? Now remember the rule of thumb. PMOS is twice the size of the NMOS. Now if you notice here, these two NMOS are in parallel. So I need to increase their width by 2, so that the resistance is equal to this one. Because once you stack the resistance, it will add up. So to modify a property of something in Cadence, you press on Q. That's the shortcut. Or you can select it and do edit properties here. Same thing. Okay. So the default width here is of course 120 nanometer. By the way, here it's supposed to be 65 nanometer, but for some reason they choose to go 60 nanometer. That's the length that they put here. I don't know why. Must be some What?
Maybe they round or truncate after.
Yeah, maybe perhaps they're rounded by 10 or something. But so I wanted to make them double, so I make this 24 and I make this 24. And now for the PMOS, these two are in parallel, so it's sufficient to keep them as 24. Oh, no, this is the width. Oh, okay. Oh yeah, I did. So what is the resistance from output to ground in the NMOS network? It is equal to, so the width is 120 nanometer. So
Actually, what's the reason to make the resistance here equals the resistance there?
it's for the propagation delay in this branch to be equal to the propagation delay in this branch. Remember, the propagation delay is RC, 0.69 RC. So we decrease R here by increasing the width so that it's equal on both sides. Okay.
The capacitance increase also.
The capacitance increase. Yes, the capacitance increase, yeah. Actually, here it should be more. This should be yeah. This should be 480 nanometer. And this should be 240. And 240. Okay. So what we still need to do is the inputs and outputs, right? So we have the things called pins. You press P to add a pin, or just do add pin. We're gonna need A, and yeah.
Why did you change the width to 48? The first one at the top, you changed the width to 48, and
Yeah.
these two
Yeah.
for 24. But I guess if they are in parallel, these two are in parallel, so the total, we need to this way the resistance of the first one would be
Okay.
oh, okay, got it.
I'll let's explain it right now. Let me put the
I forgot what I got it.
Okay. So if we transform this resistance, look, let's compute the resistance from output to VDD here. So 240 and 240, they make a transistor of 480. And 480 and 480 in series, it's 240, because so 240, if you transform it to NMOS, the equivalent in NMOS, it's 120, which is the same as here and here. So yeah, this is how you verify it. Okay, so I place these pins here. Again, I just press W to make wires.
How 480 plus 480 we get at the end 240?
It's because the equivalent resistance is equal to 240. Is equivalent to a transistor with 240. Because you remember the width. If it's in the series, then the resistance add up. So it's like you have a transistor with half the width. It's equivalent to that. You can verify it later. The resistance.
These two are in parallel.
Which one?
Yeah, these two are in
These?
parallel.
Yeah.
So so the resistance would be the resistance would, yeah.
So these two are equivalent to a PMOS with width of what? 480.
Yeah.
Okay. And then this transistor, if you put it in series with that, it will be equivalent to a PMOS with 240. Okay. So put A here. Oh, this is bad. By the way, say I want to connect A to this transistor here, but it's far away, so I don't want to cross wires and mess up my circuit. So instead, I can just label this wire. I press on L to label, and I put A, and then I press on this wire. Now these two are connected. This one and this one, they're connected, virtually connected. It's as if I've connected them together. Now let me do B. So you can see you can make a fairly large circuits in Cadence in a short time compared to Magic. That's why your project should be very, very big. No, I'm just joking. Okay, now C. And for C here, I'll just label it. Oh. Okay, so I finished my circuit. Is it correct?
Where's the output?
Oh, right. So I need to add another pin, and I choose here output. You have four types of pins: input, output, which acts as both input and output, and switch. I don't know what a switch is. Never tried it, but mostly just use the first two. So let me write out. Okay. Now this button here, it will both save and check your circuits for errors. If I go to the log window here, it tells me that system check completed with no errors. So I now have my first circuit. Okay, now we move to the simulation part. What I want to do now is I want to take this circuit and use it as a block, just like I use gates, just so that it becomes a block I can use it in other circuits. So what I do is I do design and then create cell view from cell view, and this is already all selected for me, and I want to save it as a symbol, right, so that I can use this symbol in other circuits, and I do OK. And here I can specify where are the pins, like A, B, C should be on the left and out should be on the right. I can place anything I want on the top or on the bottom, and then I click OK. And here I can edit it any shape I want. I can like draw shapes and things. If you feel artistic someday, you can create nice symbols. Okay. So if I go to my library now, you can see I have both a schematic and a symbol for my AO gate. Now I'm gonna create a new cell to test AO gate. I'm gonna call it test AO gate. Inside, I press I, and I want to place AO gate inside. Okay, I can place as many AO gates as I need. Notice I don't have to worry about VDD and ground because they're already connected inside of it. And those VDD and ground are global, meaning they're global across all my hierarchy, not just inside this block. Okay, now testing this circuit is
This means that if I have other circuits connected to VDD, they will automatically connect each other.
right, yeah.
But in the layout of Cadence, does it usually connect it anyway automatically? Or we don't work in that way?
In layout? No, in layout you have to connect it yourself. Yeah. Okay. Now let me get a bunch of inverters.